Okay, welcome back to class. Today what we're going to do is we're going to talk about atoms. We would like to answer this question, what do atoms look like? So for now, what I'd like you to do on your paper, on the top, let's just write down this question. What do atoms look like? So I'll model what to do. What do atoms look like? Let me move it down a little bit. Okay, believe it or not, you probably already know quite a bit about atoms. One thing that I can tell you is that we've been exploring atoms for many, many, many years. And one thing that they did a long time ago is they decided to just take a piece of matter and just cut it and keep cutting, keep cutting, keep cutting to see how small they could get a piece of matter. And remember that matter is basically all substances are made up of matter. We talked about like liquids and how they behave. We talked about gases and solids and so on. But what you need to know is that all matter is made up of atoms. Atoms are particles that are too small to be seen. Even with a microscope, they're very difficult to see. I mean, it requires it's called an electron microscope to actually see it. Now imagine if I take like, I don't know, any object. Let's just say this eraser. It's not a very cuttable object, right? It's matter. But let's just pretend that I can cut that and keep cutting it over and over and over again until I get to so small that it would require a microscope. Then I get a knife that's even smaller than that, and I'd cut that over and over and over again. Then I would have eventually one little particle. One particle, and that's called an atom. The word atom comes from a Greek word, and it comes from this word that means undivided. Because they believed at one time that you could keep cutting the atom or all the way down to one little tiny particle, and that particle could not be divided. So they named it an atom. It means undivided. However, some scientists have proven that you can actually cut the atom. Famous scientist named Albert Einstein. He actually proved that you could cut it. Now, it requires a lot of energy. So much energy, it actually creates a reaction. And this reaction is so strong that it actually would blow up an entire city. That's called the atomic bomb. And that's how they know that you can actually cut the atom. But it requires so much energy. And the weird thing is that atoms are so small, so tiny, that even at that small, tiny, little microscopic particle could create that size of a reaction. So atoms are really pretty strong because they do not want to be cut. They want to maintain what they call a neutral charge. Okay, we're going to talk about that as we go. But for now, what I'd like you to do is just to better understand this. I'm going to slide my paper over just a little bit so you can see everything. And these atoms are actually made up of something called subatomic particles. So I'm going to write that down because that's an important piece of information. Subatomic particles. And atoms are made up of three basic subatomic particles. Did you know that everything in the universe is made up of three subatomic particles? They are like the building blocks of the universe. You, me, everything, all pieces of matter, it's all made up of 3 particles. Now, on the very inside of the atom, there's something called a nucleus. Write this down. A nucleus. We refer to the nucleus as the center of the atom. Nucleus. So I'll underline that. It is a pretty important piece. It's the center of the atom. And I'm going to draw like a line down, like this, and like a little arrow here, because the nucleus has something in it. It's called a proton. Raise your hand if you've ever heard of a proton. Proton. Okay, a proton carries a positive charge. It's a tiny little particle found in the nucleus of an atom, carries a positive charge. So let's write that down. That's an important piece of information. Now, a proton does have mass. It's tiny. It's so tiny, in fact, they call it they weigh it, basically, and it's called an AMU, atomic mass unit. Okay, so a proton is equal to like 1 AMU. And it's so very tiny. A neutron is about the same size. A neutron is also located in the nucleus. So I'll draw another arrow down, and then I'll write the word neutron. Neutron. And I'm writing it under here because it's also found in the nucleus. A neutron. Now, a neutron has no charge. So they are significant, which means that they're important, but they don't carry a charge. They're about the same size as a proton, which would be about 1 AMU. So they do have mass. They occupy space, which means they have volume. Okay, I'm going to zoom out just a little bit so I can kind of move my paper up so you can see. Because next what I'd like to do is I'd like to draw kind of a little diagram of like an atom. Now, atoms are very difficult to draw. You know why? Because they're moving. There's actually pieces in it that's moving. Okay? Now, the proton itself and the neutron itself are probably not going to be moving. Okay? They're going to be in the center or the nucleus. Okay? So what I'm going to do is I'm going to draw a diagram here. I'm just going to color it with blue. You could just shade it with your pencil. And then up here, I'll make like a little key so that you can remember which one's which. Okay? So this one here is the proton. And then the circular one without blue, it's just a white color. We're going to call that neutron. Okay? Now, this would be the nucleus. That's the center. Okay? So, under that, I'd like you to write the word electron. Electron. Because that's the other part of the atom. Now, electrons are the moving parts of the atom. Electrons are kind of weird. We're going to talk about why here in 1 second. Electrons. Electrons carry a negative charge. So I'm going to draw like a little negative symbol. I'll put it in parentheses. And under it, I'm going to write negative. Negative. So, really you want to be like a proton and be positive. You don't want to be like an electron because they're negative all the time. Nobody wants to be around something negative all the time, right? So we're probably going to just say be like a proton, not an electron. Okay, so we have our negative charge. All right. Now, is the electron part of the nucleus? No. It's actually moving around. It's moving around in what they call orbitals. So I'm going to write that down. They move around. That's kind of a key concept. They move around. They're kinetic. And all matter has electrons in it. And an orbital is pretty much the path that the electrons like to take. Okay? So imagine the solar system. The planet Earth is going around the sun, kind of like in an orbit, right? Well, atoms kind of behave similar, not exactly the same, because they do not travel in the same path, like the Earth travels in the same path. However, the electrons going around the nucleus, they actually behave a little bit different, okay? They do stay in kind of like a shell, if you can imagine a shell. There's different layers. You might have one layer. I'm just going to draw like an electron here. I'm going to draw the negative symbol. That represents the electron. Okay. Now this path that's going around it, I'm going to draw kind of a circle going around it. Okay. Now this circle could actually be going in a three-dimensional way. It could be going around it. So just imagine a shell covering that. Okay? And imagine another shell or another orbital around that. I'm just kind of drawing a circle around it. Now that circle does represent the shell, but it's kind of hard to draw the three-dimensional electrons on it. Okay? Now, since it's moving, these electrons are itty bitty. They're so tiny. They're so tiny. I know I drew them with the negative symbol here, but really if I were to look at the actual size of the electron, I'll just draw like a little speck on here. I drew the negative sign so that you can see it, but the actual electron in comparison to the nucleus is so itty bitty, it does not even really have much mass to it. Okay? Now, the inside, the nucleus has mass. It has 1 EMU. However, the electrons, they do not carry very much mass. Okay? But they're so insignificant that people they ignore it. They ignore the weight of it. So when we talk about this element of this atom, we just are basically looking at the nucleus. That's the most important part. Okay? And that's pretty important to know. So let's take a quick look here. I'm going to stop this. Okay, so here we have a general model of what an atom would look like. Now, different atoms contain different amounts of protons. That's what makes an element different from another element. Gold, for example, has a lot of protons in it. Okay, so therefore you would have a lot of these little pieces in the inside in comparison to maybe silver. Silver does not have as many in there. So that's why you have gold and you have silver. And all it really is just the difference of how many protons, neutrons, and electrons. Now, most atoms like to have what we call neutral, which means that they have the same electrons as protons. That's generally what they like. They try to keep the same amount of electrons as protons. But not always. They can change. But this gives you a basic idea of what an atom would